Hello everyone and welcome back to the tutorial. In this part of the tutorial we are going to be talking about and setting up FlexMatch, which is basically GameLift's matchmaking system. We are going to create what is called a matchmaker, aka a matchmaking configuration, which uses a rule set to place specific players into a match and uses a queue to decide which fleet to place a game session on. The rule set can be customized for specific game modes like a team-based competition or a large free-for-all, for example. We will also have to set up an Amazon SNS topic for retrieving matchmaking event notifications. SNS stands for Simple Notification Service. In addition to that, we will have a Lambda function subscribed to this SNS topic, and this Lambda function will write information about these matchmaking events to a table in DynamoDB so that our clients can read this table through a client service to get the latest updates on their matchmaking requests. Now you may be asking, this sounds really complicated. Why can't the client just call a GameLift function through the client service to get the latest status on their matchmaking requests or game session placement requests? The reason is that generally the GameLift team does not recommend calling these functions, which are known as describe matchmaking and describe game session placement, because there are throttling limits for how often these functions can be called at a time that GameLift actually enforces. So for a game in production with a lot of clients trying to get into matches, you could easily exceed those limits. With that said, let's get started. The main component of FlexMatch is the matchmaking configuration, also known as the matchmaker, but the matchmaker requires a couple of things. The first one is a rule set, so let's go ahead and make one. To do so, go to the GameLift dashboard and click on dashboard up here. Select matchmaking rule sets and then click on create rule set. Before we continue though, I need to point out that the rule set has to be in the same region as your matchmaking configuration, and it's also recommended but not required that your queue be in the same region as your matchmaking configuration as well, in order to reduce communication latency between the matchmaker and the queue. However, this may be problematic for some of you because matchmakers can only be made in certain regions. Therefore, rule sets can only be made in certain regions too. We will have a link in the description below that has a list of all the regions where you can place a matchmaker. Since we went over making a queue in the last part of the tutorial, I'll leave it up to you guys if you want to recreate the queue in the same region as your matchmaker, but again, it's only recommended, not required. In general, it is recommended as well that the matchmaker be placed on the closest region to either your potential clients or the client service. Back to the rule set. I want to talk about exactly what it is. A rule set defines two key elements behind how your matchmaker will make matches. The first one is the team structure and size. So for example, how many teams in a match and how many players on each team. And the second element is how to evaluate players to find the best possible match. For instance, do we want each team to be balanced in terms of player skill or rank? Or do we want certain amounts of specific characters or positions on each team? Those are the two main features of rule sets. There are more components in a rule set, including special match processing for large matches, which in FlexMatch terms means greater than 40 players, player latency requirements to protect players' gameplay, relaxing team requirements or match rules gradually if no match can be made after a certain period of time, and special handling for match requests that contain multiple players. We won't be going over all the components of rule sets in this tutorial since we're just going to make a very basic rule set, but if you are interested in more complex rule sets, then I highly encourage you to check out the links we will have in the description below with regards to rule sets. Alright, for the name of the rule set, we can name this anything, so I'm just going to name this GameLift tutorial rule set. And for the actual rule set, we're going to use one of the examples that GameLift has in their documentation. So go to the FlexMatch rule set examples page in the GameLift developer guide. Link will be in the description below, and under where it says example 1, create 2 teams with evenly matched players, scroll down to this grayed out block of JSON text and copy it by clicking this clipboard button at the top right. And then go back to the GameLift console and just paste it here in this rule set box. Scroll up on this rule set so that we can make one small change, but before that, let's analyze this rule set from top to bottom. Starting from the top, there's a name attribute for this rule set. The name can be anything, so we will keep the existing value, aliens versus cowboys. Then there is a rule language version attribute, which is the version of the property expression language for creating FlexMatch rules. This value has to equal 1.0 unless they update the rule set language. Next is player attributes, which are individual player characteristics that you want FlexMatch to use for placing players into matches. Each attribute has to be an object, and they have to be defined here in an array called player attributes. Each attribute has to have a name, which can be anything, and a type, which has to be either number, string, or string map. In this case, the name is skill and the type is number. The default field right under type is optional, but currently when the client makes a matchmaking request, they will specify this player skill attribute in their request. Otherwise, this skill attribute will be defaulted to a value of 10. Below player attributes, we have the teams attribute, which allows you to describe the structure and size of the teams for a match. Each match has to have at least one team, and then you can define as many teams as you want after that. And the sizes of each team don't have to be the same. In this case, the team sizes are pretty much the same. The first team, which is an object in an array called teams, has the name Cowboys, and the maximum number of players on this team is 8, while the minimum number of players on this team is 4. All three of these fields are required for each team that you define. The second team, which is called Aliens, has the exact same max players and min players as the Cowboys team. There's also an optional field that you can add to a team that you don't see here called quantity, which can be used if you want to create more than one instance of a specific team. For example, if you wanted 2 Cowboy teams or 3 Aliens teams in a match, but we are not going to use the quantity attribute because by default FlexMatch will only create one instance of a team if you don't specify the quantity attribute, and that's what we want. We just want one Cowboy team and one Alien team. Another note on the min players and max players attributes, FlexMatch will always try to fill teams to the max player size, but it will create teams with fewer players than the max player size when the min player size allows it. For instance, if there are 10 clients looking for a match, then FlexMatch can make a team of 5 aliens versus a team of 5 cowboys using those 10 players, because a 5v5 falls in the range of possible team sizes for both teams, and that range is from 4 to 8, which 5 falls in. To make testing easier in this tutorial, since we are going to be testing on one computer, let's just change min and max player sizes to 1 and 2 respectively for each team, because we're not going to be running 8 or more clients. That might be a little hard for one computer to handle. So let's proceed to change these values. So starting with the Cowboys team, by where it says min players, change that to 1 and max players to 2, and do the exact same thing down here for the Aliens team. With these new team sizes, when we get to testing eventually, we will now be able to start matches with 2 to 4 clients total. But how does FlexMatch know which team to put a player in and how big each team will be? That will be covered in the rules attribute. So let's scroll down a little bit so that we can see all the rules. The rules attribute is an array containing objects. Each object is a separate individual rule, but all rule objects in this array will be applied when making a match. These rule statements define how FlexMatch evaluates players for acceptance into a match. These rules can apply to specific players, teams, or the entire match. For each rule, 2 fields are required, name and type. The description field is optional. Every other field added will depend on the type attribute. So for example, let's look at the first rule, named fair team skill. This rule is of type distance, which basically checks if the difference between 2 number values is within a certain range. The measurements attribute is generally a list of player attribute values that you want to check the distance or difference for. In this rule, it's square brackets and then in quotes, average in parentheses, teams, square bracket, star, dot players, dot attributes, and then in square brackets, skill, which will return the average skill level of each team in the match. Since there are 2 teams, it will be a list containing 2 values, First one being the average skill level of the aliens, second one being the average skill level of the cowboys. In case you have forgotten, skill level refers to the player attribute that we talked about earlier. Then, the reference value is a number value to measure distance against for each value in the measurements list. In this rule, the reference value is, in quotes, average, in parentheses, flatten, in parentheses again, teams, square brackets star.players.attributes, and then in square brackets skill, which will return the average skill level of all the players in the match. So the average skill level of each team will be measured against the average skill level of all the players in the match. Measured against just means taking the absolute value of the difference. And then you can define a range of acceptable distance or difference values for each measurement by defining either a min distance or max distance attribute. In this rule, there's a max distance of 10, meaning that the difference between the average skill level of each team cannot be more than 10 away from the average skill level of all the players in the match. If max distance here was replaced with min distance, then we would achieve the opposite effect, and the difference between the average skill level of each team has to be at least 10 away from the average skill level of all the players in the match. But let's just leave the rule as it is and not change it. The next rule is called equal team sizes, and we are going to change the description because earlier we changed the min and max player sizes to 1 and 2 respectively. So now instead of 4v4 all the way up to 8v8, a match can only have either 1v1 or 2v2. According to this rule, which is of type comparison. Comparison rules compare a player attribute value against another value similar to distance rules, except instead of measuring the difference between two number values, comparison rules apply a comparison operation such as less than or equal to, not equal to, greater than or equal to. In this equal team sizes rule, the operation attribute is equal. Comparison rules can either compare all the values in the measurements array attribute to a single reference value, or they can compare an attribute value across all players in a team or match. But when comparing attribute values across all players in a team or match, you would omit the reference value attribute, and you can only use equal or not equals for the operation. For example, you may want a rule that requires all players to choose the same game mode. But this equal team sizes rule is comparing each value in measurements, which is only one number, the number of players in the cowboy team, and comparing that value to the reference value, which is the number of players in the aliens team, using the equal operation. Basically, this rule makes sure that the potential two teams in the match have the same amount of players. There are more rule types, but we will not go over them in depth in this tutorial. If you want to see all the possible rule types, then we will have a link in the description for that. FlexMatch will make a match and assign players to teams based on these two rules, but there may be cases where you have a set of clients looking for a match and no combination of teams can satisfy these rule requirements, which is why FlexMatch introduced the concept of relaxing match requirements over time, and you define how much to relax the rules by over what period of time in an attribute called expansions. These rule expansions can help ensure that if a quote-unquote perfect match cannot be made, then perhaps the best available match can be made. You can make as many rule expansions as you want and apply them to different rules. Therefore, these expansions have a lot of functionality. For example, you can relax player skill requirements, increase acceptable player latency levels, or decrease the minimum number of players required. By relaxing your rules, you are gradually expanding the pool of potential players that can be matched. To make an expansion, you would define an array called expansions, and you would add an object with two required fields. The first one is target, which is the rule set element to be relaxed. In this rule set, the value to be relaxed is the max distance attribute of the fair team skill rule. The second required field is steps, which is an array of step objects, each containing a wait time seconds and value attribute that allows you to relax the attribute defined by the target in multiple stages. For example, in this expansion, after 5 seconds from the creation of the youngest matchmaking request currently in the pool of client requests, if a match cannot be made, then the max distance attribute of the fair team skill rule will be changed to 50. So now the average skill level of each team only needs to be within 50 of the average skill level of all the players in the match. But if a match still can't be made with that rule expansion applied after 15 seconds from the creation of the youngest matchmaking request, so technically 10 seconds after the first expansion was applied, then the max distance attribute is changed once again to 100. Therefore, the average skill level of each team now only needs to be within 100 of the average skill level of all the players in the match. And FlexMatch will apply this new expansion until the requests time out, or a new request is made and then the expansions get reset and the original rules are used once again. Essentially, every time a new request is made, then the expansions get cleared and the original rules are used again. Just another note, all the step objects in the steps array have to be ordered in ascending wait time seconds order, and the wait time seconds attribute can never be greater than the request timeout, which we will define when we create a matchmaking configuration. And also, I want to mention that when I say 5 or 15 seconds after the creation of the youngest matchmaking request, I need to clarify that it is 5 or 15 seconds after the creation of the youngest matchmaking request that is active and in searching status, so not in fulfilled nor completed status. FlexMatch loops through all the active requests many times per second, so it will constantly check for how long the youngest active matchmaking request has been looking for a match, and using that time, it will determine whether or not to apply a rule expansion. This is good to know because you may have a bunch of quote-unquote old matchmaking requests that do find a way to get fulfilled somehow due to that split second between new matchmaking requests getting fulfilled and created, where the rule expansions apply momentarily and FlexMatch is able to gather enough of those quote-unquote old matchmaking requests together into a match using that rule expansion. Okay, that's pretty much all there is to this example rule set, so let's go down and click on validate rule set to make sure that our syntax is proper, and it clearly is because it says matchmaking rule set is valid. And keep in mind that rule sets cannot be modified once they are created, so after making sure the rule set is done, go ahead and click on create rule set to create your rule set. Alright, the next thing we have to create for our matchmaker is a SNS topic to receive event notifications from our matchmaker. So click on services up here, search for SNS, and select simple notification service. From here, type a name for your new topic, which can be called anything. We're going to call it FlexMatch event notifications. Then click on next step. That should have taken you to this details page where you should see a display name field that we will leave blank since it's optional. Underneath details, you have a section called encryption. You can select enable encryption if you want, and that will enable what is called encryption at rest. SNS can use customer master keys powered by AWS KMS, which stands for Key Management Service, to encrypt your messages as soon as they arrive to your topic, and to decrypt your messages as soon as they are sent out of your topic. That's why it's called encryption at rest and not encryption in transit, because this option only makes it so that your messages are encrypted while they are in the topic. However, Amazon can also handle encryption in transit with SNS topics using TLS certificates issued by ATS, which stands for Amazon Trust Services. Kind of similar to the certificates we talked about in the last part of the tutorial. If you want to know more about encryption at rest for messages sent to SNS topics, then we will have links in the description below for more information, because in this tutorial we are not going to enable encryption. Although it is very useful and probably recommended, I would suggest if you do this, then instead of using the default customer master key that is automatically generated, make a key yourself through KMS. But again, we are not going to go over this, so leave it so that the disable encryption option is selected. Next up is the access policy section, where you can configure who or which services has access permissions to your topic. Here we can define who and what can publish messages to this topic as well as subscribe to this topic. We have to edit the default policy to allow the GameLift service to publish to this topic so that this topic can receive event notification messages from FlexMatch. So to do that, let's click on advanced here and then scroll all the way down to the bottom. and after this last squiggly bracket before the square bracket, just type in comma, and then type in another pair of squiggly brackets and expand those, and then type in SID in quotes colon, and then in quotes whatever you want the statement ID to be. It can pretty much be anything as long as it doesn't conflict with another statement ID within the same policy. So you can't have duplicates. If you have a statement with ID 1, you can't have another statement with ID 1. So we're just going to call this underscore console underscore pub underscore 0. And then let's just add a comma. And now we're going to add effect colon allow. And then comma principal colon squiggly brackets, and inside those we're going to have service colon in quotes GameLift.amazon.aws.com, and let's have a comma after principal, and then we'll have action and colon SNS colon publish comma, and then the last field will be in quotes resource colon, and in quotes the ARN of your topic. So it's actually already in the default policy. It's in the statement above. If you go to the statement above and see this resource field, for me it's on line 22, and just copy this value here because that's the resource ARN of your topic, and then just copy that and paste that here. And that is pretty much it. You basically create a statement in your policy that allows the GameLift service to publish to your SNS topic resource. The next section, called delivery retry policy, has to do with how SNS retries to send messages that fail to deliver to HTTPS endpoints. By default, SNS will try to resend the message in the case of delivery failure up to 3 times with a 20-second delay between each retry. You can edit these values yourself if you want to change them by unchecking this checkbox by where it says use the default delivery retry policy. But for this tutorial, we are not going to mess with this, so make sure you are using the default delivery retry policy. Next section, delivery status logging. We are not going to go deep into this, but you can configure this yourself if you want to log the delivery status of messages to CloudWatch. And the last section is for tags, which, like all of these sections besides the details section, is optional. And again, we will have more information about all these sections and articles linked in the description below. Finally, let's create our topic by clicking on Create Topic. So we have successfully made our SNS topic that will receive messages from GameLift with regards to matchmaking events. However, we still need a way to get information about these events to the client. As far as I know, clients can't subscribe directly to the SNS topic. There may be a way to have the Unreal Engine game client subscribe directly to the topic, but assuming we don't have that capability, we can write an AWS Lambda function that subscribes to this topic. So every time a message gets published to this FlexMatch event notifications topic, our Lambda function will get called, and what we can do in this Lambda function is write information about the event to a table in DynamoDB that the client can then read from periodically for the latest status of their matchmaking request. So first, let's create the DynamoDB table. So to do that, go to services up here and type in DynamoDB, and then just click on DynamoDB. So what is DynamoDB? It is a fast and flexible NoSQL database service managed by Amazon that supports key value and document-like data structures. Let's go ahead and make a table by clicking on Create Table. You can name this table anything, but I'm going to name it Matchmaking Tickets because every matchmaking request has a ticket associated with it. The ticket should have the latest information about the matchmaking request, and each ticket has a unique ID value generated by GameLift that we will use to allow clients to easily look up the associated ticket item in the table for the latest information with regards to their matchmaking request. This makes the ticket ID a perfect candidate for the primary key of our table. And in DynamoDB terms, item just means an entry or an object in a table. A primary key simply uniquely identifies each item in the table, so no two items can have the same key. A primary key can consist of just a partition key or a partition key and a sort key. The latter option is better known as a composite primary key because in this situation, the primary key is composed of two attributes. First one being the partition key, second one being the sort key. To better explain what a partition key is, essentially, DynamoDB has an internal hash function for determining which partition in a huge database, which chunk of space, which division of storage that this item will be stored in. And this hash function takes in one value to calculate the partition, and that one value is the partition key. Therefore, you can't have two items in a table with the same partition key because those two items will be stored on the same partition and you won't be able to differentiate between the two items. However, you can have two items in a table with the same partition key if your primary key is composed of both a partition key and the sort key, as opposed to just a partition key. With the sort key, you can now have multiple items in the same partition and they are now sorted by the sort key value. But you can't have two items with the same partition key and sort key value because once again, there will be no way to differentiate between those two items. So we are going to use a primary key that has both the partition key and the sort key because each matchmaking request has one ticket associated with it. But when that request gets updated, that same ticket also gets updated. So we have to be able to retrieve the latest updates with regards to a single ticket, which can be referenced by a ticket ID. So let's make the partition key ID and we'll keep it as type string. However, we also have to sort all the updates to this ticket by some sort key. So let's click on this checkbox by where it says add sort key. Let's call this sort key rank and we'll make it type number instead of string. The reason for this, because you may be thinking, why not, for the sort key, just use some timestamp value for when the matchmaking notification arrives to either SNS or to the Lambda function subscribed to the topic. Although SNS messages do have a timestamp value associated with them, messages being delivered to the topic in the same order that they were published by FlexMatch is not always guaranteed. So theoretically, a message saying that the ticket is in matchmaking succeeded status could show up in the topic before a message saying that the ticket is in matchmaking searching status shows up in the topic. Although this is a bad example and highly unlikely, things like this do happen from time to time, but we do know the order that updates to matchmaking requests are supposed to occur in. For example, if we look at this list of FlexMatch matchmaking events, link will be in the description below, the words you see on the right side of the page starting from matchmaking searching down to matchmaking failed kind of summarizes the order of status updates to matchmaking tickets from top to bottom, start to finish in a one-directional flow. So we will be ranking the events from 1 to 6 in our table, not 1 to 8, because in this tutorial we won't be implementing player acceptance requirements. So we will not encounter events of type accept match nor accept match completed. The flow of event notifications for a specific matchmaking ticket can vary so much, meaning there's so many combinations of events that your request can go through. So many that I'm not going to talk about all of them in this tutorial because it would take too much time. But if you want, you can join our Discord or comment down below and I would be more than glad to talk about them if you're interested. But I will give one example of what could happen. So a client makes a request and a ticket is made in matchmaking searching status. Then FlexMatch places that player in a match, so an event of type potential match created happens, and then assuming there are enough resources allocated in the chosen fleet on the queue that the matchmaker is tied to, a game session will start, and then the ticket will receive connection and player session details through an update that will place the ticket in matchmaking succeeded status, and then that's it. The request is fulfilled and the client will use that new information to connect to the game server. Another example is a client makes a request, placing their ticket in matchmaking searching status, but FlexMatch can't find the match within the time period specified by the request timeout, and the ticket gets put into matchmaking timed out status, and that's it. The request is finished. They don't get into a game obviously, but they can make a new request if they want to. So again, lots of scenarios that we don't have time to go over in this video. Back to DynamoDB. For the table settings, we will be using the default settings, but I want to have auto scaling too. And as you can see, it may say for you that you do not have the required role to enable auto scaling by default, which will be the case usually if this is the first time you're making a table in DynamoDB. So let's uncheck this box by where it says use default settings to show you what you can configure here, since we won't be changing much. So the first thing we have here are secondary indexes, which allow you to query the table on item attributes that are not part of the primary key. Next up, which is very important, is read/write capacity mode. The two modes are provision and on-demand. We will be using provision because it's free tier eligible, and of course we want to try to save as much money as possible. Unlike GameLift, the free tier for DynamoDB actually lasts beyond the 12 months after signing up for an AWS account. The DynamoDB free tier gives you 25 gigabytes of storage and can handle up to 200 million requests per month. So it's more than enough. But the difference between provision capacity mode and on-demand capacity mode, from what I understand, so don't quote me on this because I may not be correct, is that with provision capacity mode, you specify the min and max limits of the number of reads and writes per second ahead of time that you expect to occur with your table. And DynamoDB will allocate resources and work as hard as it needs to handle that expected workload. If the actual traffic is greater than what you expected, then auto scaling will be applied to adjust to the new workload capacity. Same applies as traffic goes down. This helps maintain cheap cost and high performance. The issue though is that if the actual traffic ends up exceeding the maximum provision capacity, then you lose a lot of performance due to throttling. And when a request throttles, it just fails, which may not be what you want. With on-demand capacity mode, you don't have to worry about performance, ever, because you are now paying a higher price for DynamoDB to instantly accommodate to your read and write workloads as they ramp up or down. So as you can see, if I click the checkbox by where it says on-demand, as you can see, there is no longer an auto-scaling section because there are no limits to what on-demand can handle. At the end of the day though, we're going to go with the provision capacity mode because the default settings are more than enough for our tutorial, but I would definitely recommend considering on-demand capacity mode sometime in the future because it is very useful when you can't predict traffic, the traffic is inconsistent, and the traffic goes up and down, not gradually, but very abruptly. And to enable that auto scaling we were just talking about, you will notice that you're about to authorize DynamoDB to scale capacity using the DynamoDB auto scaling service link role. And assuming you have the required IAM permissions, which you should if you're logged in as the root user, an IAM role will automatically be created for you once we create this table. Lastly, you could configure encryption at rest settings if you want. We went over encryption at rest earlier in this part of the tutorial, and it's still pretty much the same, and we're not going to add tags, so let's click on create so that we can create the table. One last thing we have to do with this table is add a time to live attribute. Time to live is a part of DynamoDB that lets you define when items in a table expire so that they can be automatically deleted from the database after a certain period of time being in the database. This could be useful because there's really no need to keep information about matchmaking requests stored long term, especially after a request is completed. Maybe if you want to do some kind of analysis later on, but we won't be doing that in this tutorial. So to get started, let's click on this Manage TTL button by where it says Time to Live attribute. You can name the TTL attribute whatever you want. I'm just going to name it TTL. We won't be messing with DynamoDB streams and previews, so let's just click on continue. And that's it. Now when you add items to this table, you can specify a TTL attribute, which is of type number and is in Unix epoch time format. So each item in this table will be deleted by the time specified in the TTL attribute for that item. Now that we have the table that we will be storing matchmaking ticket information in, let's start creating the Lambda function that will ultimately subscribe to the topic and write items to this table. To do that, go to services up here and look up Lambda, and then click on Lambda run code without thinking about servers. From here, go to the right and click on the button that says create function. and make sure author from scratch is selected because we are making this function from scratch. And for the function name, you can call this anything, but I'm going to call it track events. And for the runtime language, Amazon actually offers a variety of languages you can use. For this tutorial, because I find it easy to work with JavaScript, Node, and NPM, we will be using the newest version of Node.js for all of our Lambda functions. So just leave that field alone. And under permissions, if we don't touch anything, when this function is being made, a new role will be made for this function with basic permissions to write to logs in Amazon CloudWatch. With all that said, let's go ahead and click on Create Function. Now that the function is created, let me just quickly explain what AWS Lambda is for those who are not familiar with the service. Lambda is a service that lets you run code in response to events. In this case, for this specific function, it will be called in response to whenever FlexMatch sends a matchmaking event notification. Later on in this tutorial, we will have functions that get executed in response to API calls. The advantage of AWS Lambda is that it truly embodies the term serverless. You just write the code and all the server maintenance and provisioning is done by Amazon. As for costs, don't worry too much because the free tier for Lambda includes 1 million free requests per month and 400,000 gigabyte seconds of compute time per month. And this extends beyond the first 12 months of your AWS account's existence. If we scroll down, you will see that there is sample code for our function. Right now, every time this function gets invoked, a response object with the status code of 200 and a body saying hello from Lambda will be returned. You should try to code your Lambda functions so that they always return a response, preferably in JSON format. With most of the Lambda functions that we will be writing in this tutorial series, there will be a dependency on the AWS SDK node module, which is very big and bulky, and if we were to upload the node modules needed for this function to Lambda, we would not be able to use this beautiful inline code editor because Amazon only allows you to edit Lambda functions in this editor window if the size of the combined files, including the code you write and external modules that we add, does not exceed a certain size. The function would still be callable, just not editable within here. However, Amazon does have a way for you to upload libraries and packages to Lambda separately from your functions, and in a way so that these node modules can be shared by all of your Lambda functions. That way is called AWS Lambda Layers. A Lambda layer is a zip archive that contains libraries, a custom runtime, or other dependencies. With layers, you can use libraries in your function without needing to include them in your deployment package. But before we make a layer, we still need a way to get the actual packages so that we can upload them to this layer. And we would do this locally, so let's install Node.js on our computer. Link to the download for this will be in the description below. Node.js is a JavaScript runtime, meaning it has the capability of running JavaScript outside of a web browser, and it also comes with the Node Package Manager, which lets us install any one of the many open source modules out there, including the AWS SDK. So let's go ahead and under where it says download for Windows and where it says recommended for most users, click on this button. This will give us Node version 12, which at the time of filming this video is the latest stable version of Node. When the installer is finished downloading, go ahead and start it up. In the wizard, select Next. Select I accept the terms in the license agreement and click on Next again, and then Next, and then Next, and then Next, and then Install. Do you want to allow this app to make changes to your device? Just select Yes. Once the installation is finished, let's just check that Node.js successfully installed. So click on Finish here and let's open up Command Prompt. And then type in npm-l and press Enter. And this command will list out every npm command that you can run. As long as you see something like this and Command Prompt recognizes that npm is a legitimate command, then the installation was successful. While we are here in the command prompt, let's go ahead and retrieve the modules we need for the Lambda layer. So I'm going to cd into my documents folder. You can do this wherever you want. I'm going to make a new directory called Lambda layer by typing out mkdir and then in quotes Lambda layer because I'm going to add a space to this directory name. And then I'm going to cd into this Lambda layer folder that I just made. Then I'm going to make a new directory called Node.js. Then I'm going to cd into Node.js. And From here, I'm going to install whatever node modules I need, which right now is the aws-sdk, which is a library that contains functions related to every single AWS service. So let's do that by typing out npm install aws-sdk and press enter. Once npm install is done, go to File Explorer, specifically where you put that Node.js folder. Open it up and you will see a package log.json file as well as a node modules folder. Open up node modules and you will notice that one of the modules is called AWS SDK. Everything here looks good, so let's go back to the directory containing the Node.js folder and let's zip up Node.js by right clicking it, selecting 7-zip, and then select add to archive, and then press OK. We are now ready to make our Lambda layer. Go back to the Lambda function in the AWS console, expand the left side by clicking on this hamburger menu button and click on where it says layers. And then click on create layer. For the name, you can name it anything, but I'm going to name it GameLift tutorial layer. I'm going to leave the description blank since it's optional, and upload your modules by clicking on this upload button. Find out where that zip file we just made is located, and then select it and click on open. For the runtime, choose the version of Node.js that you are using. In my case, I am using the latest version, which at the time of filming this video is Node.js 12. And then once that's all done, click on create. After the layer was successfully created, go back to the Lambda function that we made earlier by expanding the menu on the left side again, but this time select functions. Select our function, and let's add a layer by clicking on where it says layers here. And you should see a section called layers pop up underneath. From here, go ahead and click on the button that says add a layer. In this layer selection window, keep the checkbox by where it says select from list of runtime compatible layers selected. And then for the name field, click on this drop down menu and select the layer you just made. And then for the version, click on 1. And then click on add. And that's it. You will see that the number of layers for the function in the middle of the screen is now 1 instead of 0. We can start importing the modules from the newly added Lambda layer in our code, so let's scroll down and actually get started. Going to zoom in inside this editor window by pressing Ctrl+ a few times so that it's easier for you guys to see, and get rid of the code inside this function. We will start by importing some modules, and we will be doing this outside of the handler function. The first one will be the AWS SDK, so type out const AWS equal require in parentheses and in quotes AWS-SDK. Next, we will be constructing a DynamoDB service object by typing out const DynamoDB equal new aws.dynamodb. And this constructor takes in one parameter, which is an object, and this object can have many fields, but for our purposes, we're only going to define one property for this object parameter, and that property will be called region, and the value will be in quotes US-East-1. Now, if you're not operating in the region defined by the US East 1 code, use the associated region code with the region you are operating in. I'm just going to close it off with a semicolon. And next up, we will make an object that will map matchmaking statuses to a rank, because again, SNS messages are not guaranteed to be delivered in the same order they were published. So we could get events out of order, but we do know the relative order of how events should arrive. So let's create a map called type to rank, and we're going to set that equal to an object. And the first key value pair in this map will be matchmaking searching colon in quotes 1, and then the next key value pair will be potential match created colon in quotes 2, and then we'll have matchmaking succeeded colon 3 in quotes, and then matchmaking timed out colon 4 in quotes, and then matchmaking canceled colon 5 in quotes, and finally matchmaking failed colon 6 in quotes. I'm just going to close that off with a semicolon. Let's now go back inside the handler function and create two local variables. The first one will be called message, so type out let message. This will represent the incoming message from SNS. And the next local variable will be called response, so type out let response. And this will represent the response that we send back to whoever or whatever calls this Lambda function. Then we have to check if the incoming event object has an array called records, because the incoming message should be in an array in the event called records. So to do that, let's type out if parentheses event.records double ampersand event.records.length greater than 0, and then squiggly brackets, because we not only want to check that the records array exists, but we also want to check if the records array has at least one object in it. Then let's extract the first record in this array and put it in a variable. So to do that, let's type out const record and set that equal to event.records square bracket 0. And for some reason, SNS will always send messages one by one. So each time this Lambda function gets called, there will never be more than one message inside event.records. Therefore, there's always at most one entry in the records array. Don't ask me why they do this. I am just as confused as you guys. Next, we have to check if this record object has an SNS property that contains a message property. So to do that, type out if parentheses record.sns double ampersand record.sns.message. And inside here, if the record does have an SNS property that contains a message property, we're going to print out this message to the console because I want to show you guys later on what the event notification from FlexMatch looks like. So to do that, type out console.log and then in parentheses and in quotes, message from GameLift colon plus record.sns.message. Lastly, we will set our local variable called message to json.parse in parentheses record.sns.message, because the message arrives in the form of a JSON string. So we're going to parse it to an object in order to easily access fields within the message. Next up, we have to check if we actually got a message from SNS. If not, or if the message somehow did not come from FlexMatch, which is highly unlikely, but let's type it out. If parentheses exclamation point message double pipe message square bracket and then in quotes detail dash type not equal in quotes GameLift matchmaking event and then squiggly brackets. And in this case, we will send an error response. So let's set response equal to squiggly brackets. So this will be an object, and the first property will be called status code, and we're going to set that equal to 400, comma, next property will be called body, and we're going to set that equal to json.stringify in parentheses, and then in squiggly brackets, we're going to have a error field, and then we're going to set that equal to, in quotes, no message available, or message is not about GameLift matchmaking. And we will return this response, because if there's no message or if it's not a GameLift matchmaking event message, then we don't want to do anything else in this Lambda function. So now let's make two more local variables. First one will just be the detail property within the message object. So just type out const message detail and set that equal to message.detail. And the second variable will be a parameters object that we will be passing into a call to the DynamoDB batch write item function. So let's create it by typing out const DynamoDB request params and set that equal to squiggly brackets. And for batch request, the only property in this object is always called request items. And we're going to add a colon and then some squiggly brackets here. And inside request items, the property has to be named the table that you are operating on. So in our case, it's going to be called matchmaking tickets. and then the value for this property will be a blank array for now. Eventually this array will be populated with a bunch of put request objects. Now you may be asking, why are we going to perform a batch operation? The reason is that matchmaking events coming into this function can be applied to multiple tickets at once. For example, if an event of matchmaking succeeded arrives, then only one message will be sent for all the client requests involved in that successful match made. So we don't know how many items we will be writing to the matchmaking tickets table in one call to this Lambda function. It can be 1 all the way up to 4. Also, I'm just going to add a semicolon here. With that said, let's check if this message even has any tickets. So to do that, type out if in parentheses !message detail.tickets double pipe message detail.tickets.length == 0, and then some squiggly brackets, because again, even if the detail property of the message object has a property called tickets, we don't care if that tickets array is empty, meaning it has no tickets. So in this case, we'll set response equal to squiggly brackets, and in those squiggly brackets type out status code :400 comma body JSON.stringify in parentheses, and in squiggly brackets type out error : in quotes no tickets found. Then add a semicolon there, and we're going to return this response because again, if there are no tickets found, then we don't want to do anything else in this Lambda function. If there are tickets, then let's proceed to loop through all the tickets in the messages detail object. So type out for in parentheses const ticket of message detail.tickets, and then squiggly brackets, and for each item we will have a local variable called ticket item. So let's write out const ticket item, and we're going to set that equal to a blank object. The ticket item will represent one of the items that we will be writing to the matchmaking tickets table. And for each ticket, we will set some fields in this ticket item object. So the first one will be the partition key, the ID. So let's type out ticket item.id and set that equal to squiggly bracket s:\ticket.ticket ID, closing squiggly bracket. And you may notice the format is a little interesting here. I am making the ID attribute of the item that will be written to the table an object where there is one property that is named the type of the attribute. S in this case stands for string. You'll have N for number, M for map, and L for list. Then the actual value of the attribute, which in this case we are getting from one of the tickets from the message, is the value of the type property, which in this case is called S. I knew this would look a little confusing, so I just want to explain this now ahead of time, because this is what every property of this ticket item object will look like, because that is the format that DynamoDB accepts when calling their functions. The second field will be the sort key, the rank. Luckily we made the values in the type to rank object all strings, so we don't have to convert anything. Let's set the rank attribute by typing out ticket item.rank and set that equal to squiggly bracket n:type to rank in square brackets message detail.type, and then a closing squiggly bracket. And you may notice that we are using the type property of the messages detail object to determine which rank to set this attribute to. Similarly, the next field will be the type of the matchmaking event, which we just referenced through message detail.type. It can take on values such as matchmaking searching, matchmaking canceled, and etc. Let's set the type attribute by typing out ticket item.type and set that equal to squiggly bracket s:\message detail.type and then closing squiggly bracket. And the next field will be the time to live attribute. In our case, I'm going to set the TTL property so that the item will get deleted from the table an hour after it was put into the table. You can make this value whatever you want, but let's go ahead and type out ticket item.ttl and set that equal to squiggly bracket n:, in parentheses math.floor date.now parentheses divided by 1000 plus 3600, and then parentheses .toString parentheses squiggly bracket semicolon. Date.now returns the time in Unix epoch format, but in milliseconds, so we have to divide by 1,000 because Amazon takes it in seconds. And then we do the math.floor operation because we don't want any decimal points here. But you guys can replace the 3600 that I add to this value with whatever positive number to make it expire either sooner or later. And we have to convert this to a string because for some reason when adding or updating items in a table, all the values for all the attributes have to be in string format even for number fields. I don't know why, but that is just how it is. Now for messages of type matchmaking succeeded, we'll have to add more fields to this ticket item. So let's add a check for that by writing if parentheses message detail dot type equal in quotes matchmaking succeeded, and then squiggly brackets. When the incoming event is of type matchmaking succeeded, each ticket will now contain new information such as the newly generated player session IDs associated with the players, which are needed to authorize the players when they join the server. And the message itself will now contain server connection information such as an IP address and port, which the clients will use to connect to the server. So let's go ahead and let's add a players property to the ticket item by typing out ticket item.players and set that equal to squiggly bracket L colon square bracket squiggly bracket. And the reason why this is a list instead of one player object is that technically a ticket can have multiple players associated with it. In this tutorial, we won't deal with that scenario, but just in case you guys do, we will make the players property a list. So let's pretend for now that the ticket can have a variable amount of players tied to it. So let's make a variable for the players in the ticket by typing const players and set that equal to ticket.players. And we will iterate through the players in the ticket by typing for parentheses const player of players and then squiggly brackets. Let's make a variable for each player object that we will be adding to the ticket items players property. So type out const player item, set that equal to squiggly bracket m colon squiggly bracket and then another squiggly bracket. And just a heads up that for the attributes that we set in this player item, all the values will come from the player we are iterating on in the ticket. And the first attribute we will set in this player item will be the player ID. So type player item.m.player ID equal squiggly bracket s colon player.player ID squiggly bracket. Just a note about the player ID field, the value for this attribute is actually going to be generated client-side, specifically in the client service, but we'll get deeper into that later in the tutorial. The point is that this is not new information that FlexMatch generated. On the other hand, the player session ID for each player is a unique value generated by the GameLift service so that it has a way to confirm the identity of each client joining the game server. So let's set this field in the player item by typing player item.m.player session ID equals squiggly bracket s colon player.player session ID squiggly bracket. And according to the GameLift documentation, it is also recommended for the client to pass both the player ID and player session ID when connecting to the game server, although you could probably get away with just having the client just pass one of the two IDs instead of both, but we are going to follow what the official documentation recommends, which is why we are storing both these values in DynamoDB for the client to access. So let's finally add this item to the players list by typing ticket item.players.l.push in parentheses player item. Then, outside of this for loop, but still in the if statement, let's add the game server connection details to the ticket item by typing ticket item.game-session-info equals squiggly brackets, m colon squiggly brackets again, IP address, colon squiggly bracket s colon message detail.game-session-info.ip address, squiggly bracket comma port colon squiggly bracket n colon message detail.game-session-info.port.to string parentheses squiggly bracket, because the port is technically coming in as a number, and every attribute in an item in a DynamoDB request has to have a value in string format. That's why I'm calling .toString on the port value. I'm just gonna add a semicolon here. Now, just a note, it's not generally recommended to store connection details like this, plain and unencrypted, really anywhere, since IP addresses and ports are technically considered sensitive pieces of information that can open your game up to DDoS attacks, for example, if they got leaked. However, for this tutorial, we are just going to keep the IP addresses and ports unencrypted just to make things easier. Also, if you did want to be more secure with connecting to the server, you would look more into the generated certificate option for TLS when we were configuring fleet settings in the last part of the tutorial. Okay, so we have finished constructing the ticket item that we will be writing to DynamoDB, so let's add a put request for this item to our DynamoDB request parameters by typing out DynamoDB request params dot request items dot matchmaking tickets dot push, and then in parentheses and then in squiggly brackets put request colon squiggly bracket item colon ticket item. Then I'm just gonna add a semicolon there. And once we have the request parameters after looping through each ticket in the event message and creating a ticket item for each ticket, we can now perform a batch write operation outside of the original for loop in order to add as many items as we need to our matchmaking tickets table. So let's write await DynamoDB.batch write item in parentheses DynamoDB request params, and then .promise parentheses .then in parentheses data arrow squiggly brackets. And in the case of a successful request to batch write item, let's make the response that we return from the Lambda function positive by writing response equals squiggly bracket status code colon 200 comma body colon json dot stringify, and then squiggly brackets success colon in quotes ticket data has been saved to DynamoDB. And I'll just add a semicolon there. So a couple things I want to mention for those who may not be familiar with JavaScript. Batch write item is an asynchronous function, meaning if we had more code to be executed after this function call, that additional code could potentially finish by the time we get a response from batch write item. However, you can make any of the AWS service functions synchronous by calling .promise on the function. And then once you call .promise, what gets returned is what's called a promise object, and you can add a .then on that promise object to catch when the original function returned a successful response. But we still need the await keyword at the beginning to pause the Lambda function until we reach the callback function past the .then. But we still need to provide a .catch to this because we also have to wait for the original batch write item function in the case where it returns a error response instead of a successful response. So to do that, let's type .catch parentheses arrow squiggly brackets, and this time we'll set the response to something negative. So response equals squiggly bracket status code colon 400 comma body colon json dot stringify, and then squiggly brackets error colon error. Then I'll just add some semicolons. And of course, we actually have to return the response by typing return response. And that's it. Our Lambda function is finally done. So let's actually save our work by clicking the save button here on the top right. So before we move on, I'm just going to quickly go over how to use the built-in test feature within AWS Lambda so that you can test your Lambda functions locally. So if you click on this drop-down menu by where it says select a test event, go ahead and select configure test events. In this configure test event window, by default, create new test event will be selected and the default template is hello world. When you make a new event, then whatever event that is becomes the new event template by default when you create a new event. And from that point on, the event template by default just becomes the last event you used or had selected. You can always change the event template by clicking on this drop-down menu and choose from a template from the list provided to you, which will include events that you made as well. You can call the event whatever you want, so I'm going to name it no tickets event, because the event I'm about to write is going to have a SNS property which will have a records array with one message object, but that message won't have any tickets. Also, if you haven't figured it out by now, this event is going to be what's passed to your Lambda function handler. So we are kind of simulating what would happen when this function gets called by whatever, and that entity that calls the function passes an event object. Now, I'm not going to write out the entire event object because that would take way too long, but I want to redirect you guys to this GitHub repository. Link will be in the description below. That will eventually have all the Lambda function code as well as test cases once the tutorial series is fully finished and released. So for example, this is the track events function, and let's click on no tickets event.text to copy the event in there. So copy the text inside and go back to Lambda and paste it in this window, and then scroll to the bottom and click create. Now that we have an event, we can test our function using that event by clicking on this test button on the top right. Make sure you have the event that you want to test with selected on the left of the test button before clicking on the test button. So you'll notice right away that a execution result window opens up on the bottom here, and it shows a response from your Lambda function as well as any logs that you printed out in your Lambda function. Now we can't test any of the matchmaking event tests that I had in the GitHub repository because this function currently does not have permissions to write to the matchmaking tickets table. So to add the specific DynamoDB access permissions to this Lambda function, scroll up and select where it says permissions at the top here, and then click on the functions role in the execution role section under where it says role name, and that should redirect you to the role in the IAM management console. From here, click on the policy attached to the IAM role. It should be the only policy under where it says policy name. Then click on edit policy. From here, click on the JSON tab, and after the last statement in this list, let's add a comma and then squiggly brackets, and then in quotes, effect, colon, allow, comma, action, colon, DynamoDB, colon, batch, write, item, and then comma, in quotes, resource, colon, in quotes. Now for this, we need the ARN value of our matchmaking tickets table. So go to the DynamoDB dashboard, go to tables on the left, select the matchmaking tickets table, and towards the bottom of the page, copy this ARN value. And then go back to the IAM management console and then paste it in for the resource. Once that's done, let's click on review policy, and we should see that the Lambda function now has limited write access permissions to the DynamoDB service. Limited because it's write permissions to one table. So let's click on save changes and then go back to the Lambda tab. Now we can test one of our matchmaking events. So let's click on this drop down menu by where it says test and click on configure test events again, and then go on create a new test event, and then go back to GitHub and let's select one of our matchmaking events. So let's do the matchmaking searching event.txt file and copy this event, go back to Lambda and paste that value in, and then for the event name, we'll call this matchmaking searching event. And then let's click on create to create this event, and then let's click on the test button to test this function with that event. Now, under where it says execution result succeeded, click on details to expand the details, and you'll notice that the response returned from the Lambda function has a body with a success property that says ticket data has been saved to DynamoDB. So if we go to DynamoDB, specifically in the matchmaking tickets table, and if you go to items, you'll notice that there's an item. Just to show you guys that the time to live attribute is working, I waited more than an hour, and as you can see, the item is no longer in the table. And there are still other test cases that I encourage you guys to run on your own, but we are going to move on. This is simply just mock data. To get real data, we still need to hook this Lambda function to the SNS topic that will be receiving event notifications from GameLift by subscribing this function to the topic. So to do that, let's go to services and let's look up SNS in the search bar and click on simple notification service. First thing you may notice is that the number of topics is now 2. Don't be freaked out because I know that many of you guys will probably be wondering where that second topic came from. Well, if we click on topics on the left side here to view our topics, you will notice that the new topic is called DynamoDB. Basically, when we made a table, since that was our first table made in DynamoDB, an SNS topic for DynamoDB was automatically created. This topic is used for setting off alarms in CloudWatch for when we reach certain read-write capacity limits. Now, it may be used for other things, but I can't think of them right now off the top of my head. But right now we are interested in FlexMatch event notifications, so click on that topic, and under where it says subscriptions, click on the button that says create subscription. The topic ARN field should already be filled out for you. For protocol, click on the drop-down menu and select AWS Lambda. You should then see a field pop up right below it asking for the endpoint of the AWS Lambda function that you want to subscribe. Just start typing in the field the name of your Lambda function, which in this case is track events. And the ARN should show up in the drop-down menu that automatically appears, so just choose your function once you see its name. With regards to the subscription filter policy, we will not be filtering out specific messages that the Lambda function will receive, so we won't be touching that section at all. For the read-write policy, you can choose to send undeliverable messages to a dead letter queue by clicking this checkbox by where it says enabled, but for this tutorial, it's not worth setting up an SQS queue for this since we're not going to be looking at undeliverable messages ever in this tutorial, so we are just going to leave this as disabled, and after that, let's create the subscription by clicking on the create subscription button. Okay, let's go ahead and test our subscription by going back to our topic, which is called FlexMatch event notifications. So click on the name of your topic and then click on publish message. From here, we are going to make a mock dummy message and send it to our topic to test if that invokes our Lambda function, which it should. I'm going to skip the subject and time to live fields because they are optional. For the message body, I'm actually going to go to the FlexMatch matchmaking events page in the GameLift documentation. Link will be in the description below, and I'm actually going to copy the first example message here of type matchmaking searching. And then go back to SNS and paste it in this window under where it says message body. And we are not going to add any metadata to our mock message, so we can skip the message attributes section and go ahead and click on publish message. Now, if you've set everything up correctly, if you go back to your table in DynamoDB, which was called matchmaking tickets, and go to the items tab, you should see a new item appear in the table. To further prove that the Lambda function did get invoked, we can check the CloudWatch log since we did add a statement in the function to print out the message. So go to services and look up CloudWatch, and then select on CloudWatch, monitor resources and applications. And then on the left side, click on log groups, find the name of your function, in this case it's track events, and click on that, and then click on the latest log stream here. And then you'll notice that around 2:50 UTC time that this function was invoked, and that is accurate. And if we expand this second message here, you'll see that the message that we published to the SNS topic was indeed sent to this Lambda function because we printed it out and it looks exactly the same. It's of type matchmaking searching, and the ticket ID was ticket 1, the player in it was player 1. So if we go back to the documentation, player 1 was the player and the ticket ID was ticket 1, and of course it was of type matchmaking searching. Now, if you guys have time, I would highly encourage you to take the other events on this page and try publishing them as messages, and then check if items are still being written to DynamoDB and logs are being sent to CloudWatch the way they should be. And since we just published a message, let's quickly talk about the SNS free tier. The first 1 million publish requests to your topics per month are free, so don't worry about SNS cost too much. The subscription request costs, on the other hand, in our case will be charged through Lambda, which also has a free tier that we will talk about in another part of the tutorial. But moving on, we now have our SNS topic fully configured to receive FlexMatch event notifications. So let's finally create that matchmaker by going to one of our AWS tabs that we have up here and go to services and look up GameLift. Then select GameLift. From here, click on dashboard and then select matchmaking configurations, and then click on the button that says create matchmaking configuration. For the name, we can call this anything. I'm just going to call this matchmaking configuration GameLift tutorial matchmaker. And since the description field is optional, I'm going to leave that blank. For the queue, we are going to use the queue that we made in the last part of the tutorial, so let's select the region that this queue is in, which in my case is US-East-1, and then you'll see another drop-down menu pop up, and if you click on this, you should see your queue. The next field is the request timeout, so essentially after what amount of time since the initialization of a matchmaking request does it time out, meaning after a certain time period, if the request could not be fulfilled and the players associated with the request could not be placed in a match, thereby resulting in an event notification of type matchmaking timed out. I'm just going to choose an arbitrary number. Again, you can make this anything. I'm just going to make this 60, as in 60 seconds, since this field takes in a number of seconds. For the acceptance required field, just leave that as the default value, which is no. We will not be dealing with player acceptance in this tutorial, so as a result, we will not be dealing with events of type accept match or accept match completed. Essentially, if you did enable acceptance required, then you wouldn't get events of type matchmaking succeeded unless all the players in a potential match notified FlexMatch that they accept the match. So acceptance required by default means that every match requires every single player to accept the match before the players can connect to the game server. And for the rule set name field, just click on the drop down menu and you will get a list of all of the rule sets made in this region. So just click on the one that we made earlier in this tutorial. Now that the matchmaker is configured to use the GameLift tutorial rule set, let's go back to the SNS page, specifically in your FlexMatch event notifications topic. Go by where it says ARN, and underneath that, copy this value. And then go back to the GameLift console, and then paste that in the notification target field. The matchmaker will now publish messages about status updates to matchmaking requests to the FlexMatch event notifications SNS topic. Next up is the additional players field. This is just the number of extra player slots that you want to remain unfilled at the beginning of the match, but these slots can be filled by players in the future. I honestly don't know much about this field, so I won't touch it. The custom event data field is for extra data that you want to add to each matchmaking event associated with this matchmaker. Again, for this tutorial, not going to touch this field. The game session data field is for extra data that you want to pass to the game server for any game session that gets created by this matchmaking configuration. We won't use this field either. The game properties field is the exact same thing as the game session data field, except in key value pair format, so we won't use that field as well. Lastly, the backfill mode field has two values. If we click on the drop down menu here, we have manual and automatic. For this tutorial, we will be doing backfill manually, meaning we will be handling backfill ourselves through code that we write in our game server. If you had automatic backfill selected, then whenever a match is successfully fulfilled, meaning that a game session was created along with player sessions, if the match did not fill up to its max capacity of players, then one matchmaking request automatically gets made that includes the players already in the match, trying to add more players who aren't already in the match to that match. However, it is only one request, so if more players get placed into that match after that initial backfill request gets fulfilled, but they don't fill the match up to its max player capacity, then another matchmaking backfill request does not get created. Same thing applies if players leave in the middle of the match. A backfill request would not get automatically created to replace the players who just left. So because of the limited functionality of automatic backfill at the time of filming this video, let's stick with manual backfill and go ahead and create our matchmaker by clicking on this create button. And guys, I know that took a while, but we have finally created our FlexMatch matchmaking configuration, connected it to a rule set and an SNS topic, and we also subscribed a Lambda function that writes items to a table in DynamoDB to that topic. That will be it for this part of the tutorial. Thank you guys for watching as always. If you enjoyed the video, then please like, comment, subscribe, join our Discord, and follow us on our other social media pages. Special thanks to our donors and patrons on Patreon, and see you guys in part 5.